So we are going to do this June 2019 paper for Pure Mathematics 2 P2 with new mark scheme. Let's see. The first question is a sequence A1, A2, A3, so on is defined by an plus 1 equal to 4 minus an and a1 is 3. Mean the first term of the sequence is given 3. Find the value of, in part a1 you have to find the value of a2. Let's do part a1. Now how we can find a2 if in this given sequence, in this general term, if in place of n I write 1, so then what will happen? A1 plus 1 will become a2. So we can get a2. So to get a2, put n is equal to 1. This is given an plus 1 equals to 4 minus an. So what I will do, in place of n I will write 1. Put n is equal to 1. It will give me a1 plus 1 will be 4 minus a1. So from here I can get a2 equals to 4 minus a1. a1 is given in the question, it is equal to 3. So I can say a2 is 4 minus 3, which is 1. And then in the second part is asked to find a107. It means we need to create a sequence first because we don't have the general term for which we can find. That's why what I need to do is I will find first few more terms, so I will get the idea about the pattern. So on the basis of that pattern, I will find a107. So let's do how we will do it. Part 2. First, I will try to find a3 also. Now I have a1, a2, I will try to find a3 also. So how I can find a3? By putting n is equal to 2 in this one. Then what a3 will be? 4 minus a2, because we are putting now n is equal to 2 here. So a3 will become 4 minus a2. What is a2? a2 is 1, we already found in the previous part. So a3 is equal to 3. In the same way, let's find one more term, so then we'll be able to decide the pattern. Find a4. Now what will be a4? I have to write n is equal to 3 in this sequence. So it will become 4 minus a3. So 4 minus a3. What is a3? Is 3. So we'll get 1. In the same way, one more, I think it will be more appropriate. Find a5. How I can find a5? By putting n is equal to 4 in this one. So I can get 4 minus a4 because I'm putting n is equal to 4. So that will become 4 minus a4. What is a4? a4 is 1. It is 3. So you can see there is a pattern. Like if I write a1, a2, a3, a4, a5, the pattern will become like that. a1, a2, a3, a4, a5, so on. The pattern will look like this one. a1 was, as we found initially, a1 was equal to 3. And then a2 was 1. Then a3 was 3. Then a4 was 1. Then a5 was 3. And so on. Same way, if I will go to a107, so you can notice a pattern in here. If it's odd value, like for a1, a3, a5, we are having the answer 3. And for the even numbers, when n is even, so we are getting it 1. So a107, n is even, n is odd, sorry, so we will get it also equal to 3. So I can say a107 is equal to 3, because whenever n is for an odd, in detail if you want to write more, you can add that one also. You can say for n equal to any odd value, we are getting the term is equal to 3. And when n is equal to even value, the term is equal to 1. That is. So now next, part B, we have to find summation, means sigma n is equal to 1 to 200 for this one. Let's write it. The same technique we have to use here also. we have to find sigma n is equal to 1 to 200. It's 2an minus 1. Now, what is the meaning of the summation term? Mean we have to add all. First, for example, I will put n is equal to 1. When I will put n is equal to 1, it will become 2a1 minus 1. Then it's summation, so I will say plus. Then I will put n is equal to 2. When I will put n is equal to 2, so it will become 2a2 minus 1. When I will put n is equal to 3, it will become 2a3 minus 1 plus so on, and in the end, at the end, it will be, when I will put n is equal to 200, it will become 2a200 minus 1. So that it will become. But now we know already in the previous part, we know that for n equal to odd value, when n is odd value, so our term, because these are the terms, this is one term, second term, third term, the term is equal to, when we are using an odd value, the term is equal to 3 that we write in the previous part. So using that technique here, I can say for when n is equal to odd, so the term will be equal to 3. So on that basis, I can say this 2a1 minus 1 should be equal to 3, and I can say 2a1, or instead of that one, we can do another thing here. We have another thing here. Rather than that one, I know that a1 in the previous part we found a1 was equal to, so why not to use a1, a2 and a3 and so on. In that case it will be more better. Okay, so I can say here it's more better if I will use here the value of a1, a2, a3, so on. So then the general pattern we can get here also. We can say it to a1. What was a1? A1 was 3 minus 1. In the same way, plus it will be 2 a2. A2 was 1 minus 1 plus 2a3. A3 will be equal to, I can say in general, I will say a3 was 3 minus 1 plus so on, and then so it will become 6 minus 1 is 5 plus this is 1 plus 5 plus so on. If continue in this way, you can notice that this is for the odd term. For odd term, we are getting 5. For even term, we are getting 1. And so on. This is even term. So it means in the last, I will get this also 5. It will be plus 5. No, sorry, it is even. So for even value, we will get 1. So between 200, half values are even and half values are odd. So each time we are having an odd value, each time we have an odd value, what we are getting for an odd value, we are getting it 5. So there are total 100 odd values. So I can say it will be 100 into 5 plus there are 100 values for which we are getting 1. So 100 into 1. So that sum will become in that case 500 plus 100, so total will be 600 in that case. That's our final answer for this one. Pretty simple, not difficult, but just you have to follow the given pattern. Question number 2 is very easy question, actually. You can say a circle C has an equation. This is the equation of circle. Find the coordinates of the center. You know, we know in general the equation of circle is x minus a square plus y minus b square equal to r square. What is a and b? We say a and b is center of the circle, while r is the radius of the circle. So to find the center, I need to convert this one in the form of, uh, I need to convert it into this form. There is another way also, but instead of that one, if you better you use this method, because then later on it will be easy for you to solve it. Okay, I can do it by two different methods, but it's better just follow this method that I'm going to do. First, I need to bring it into this form. To bring it into this form, I can write x square plus y square plus 4x minus 10y minus 21 equal to 0. This is given equation. Now from here, what can I do? I can write it x square plus 4x, mean x terms, and then write y terms, y square minus 10y, and then at the end write the constant term. Or better, in the initial step, take it to the other side. Now complete square for this one and complete square for this one. And you know the method of completing the square. How we complete the square for an expression, what we do, we half the coefficient of x. It will be 2. So add 2 square and minus 2 square in this one. X square plus 4x plus 2 square minus 2 square. Do the similar thing to complete the square for y. Half the coefficient of y is 5. So add 5 square and subtract 5 square. 5 square minus 5 square equals to 21. Now this will become a whole square of x plus 2 square, and in the same way this will become a whole square of y minus 10. And then this minus 4, this minus 25 equals to 21. Shift them to the other side. It will become x plus 2 square plus y minus 10 square equals to 21 plus 4 plus 25. Let's calculate this value. 21 plus 4 plus 25, that will give me 50. So it's x plus 2 square plus y minus 10 square equals to 50. So to write it in general, I can say, if I have to write, I can write this 50 also square root of 50 square. So it will take this form. When I took this form, you can notice if x minus a, so by changing the sign, that will give us the center. So if I have here, I can say now the center is 1. The center will be opposite sign of this one, minus 2, and the opposite sign of this one, minus 2, 10 is the center. While what is radius? Radius I will say is square root of 50. That is the radius. So we completed part 1 and 2 of the part A. That was required to find the exact value of the radius and the coordinate of the center. Then part B is the point P54 lies on C. Find the equation of the tangent to C at point P, writing your answer in the form y is equal to mx plus c. It's just like this one. Let's say if I take this circle, there is circle whose center we know already. We know the center of the circle, which is minus 2, 10. This is the center of the circle. Now we have to take a tangent at any point of the circle, and this tangent, let's suppose this is the tangent to the circle. If I will take this, this is the tangent. Tangent we know is the line that touches the circle at one point only. This is tangent to the circle. So then we know that radius is perpendicular to the tangent, and it is, the tangent is given, you have to take the tangent at point 54. Tangent is at point 54. I mean this is point 54. You need to find the equation of tangent. A lot of techniques can be used to find the equation of tangent. What I need to do is I need the gradient of this one, because I need to find it in this form y is equal to mx plus c. I need the y-intercept of the tangent, and I need to get, I also need to get the gradient of this one. To get the gradient of this one, first get the gradient of radius, because if I will take the gradient of this center, means CP, let's suppose is, what is the gradient of CP? Gradient of CP will be equal to, using y2 minus y1 over x2 minus x1. If this is y2, 4 minus y1 is minus 2 over x2 minus x1. which is 10. So that will be 6 over minus 5. Now, the tangent, this is tangent. Tangent is perpendicular to this radius. So obviously what will be the gradient of tangent? Let's say m is equal to gradient of tangent. If I will take the gradient of tangent, that will be negative reciprocal of this one, because both are perpendicular, and if two lines are perpendicular, then their gradient are negative reciprocal of each other. So it means that will be, for the tangent, gradient is going to be negative reciprocal of this, which will be 5 over 6. Now I have the gradient of the tangent, and I also have the 1 point on that one. So we can find the equation of tangent. Gradient is now m is equal to 5 over 6, and tangent is the point is through which the tangent passing is 5, 4. So we can use this equation, y minus y1 is equal to m into x minus x1. So this is our x1, this is y1. So using that one, y minus y1 equal to m to x minus x1. So I can write it as we need to write the final answer in this form, mx plus c. So what I will do, I will just take this 4 to the other side and multiply it inside. 5 over 6x minus 5 over 6 into 5 plus 4. So it will become y equals to 5 over 6x. This will become minus 30 over 6 plus 4. Let's solve this one. Minus 30 over 6 plus 4 is 9. This will give you 9. So I can say y is equal to 5 over 6x plus 9. So that is the final answer of the part B. We found the equation of the line. Easy, so many times in past papers we have seen that one. This is also another very easy question where we have to use algebra to prove that for all real values of x, x minus 4 square is greater or equal to 2x minus 9. So to prove that one, we will, whenever we have to prove algebraically something, we have two methods. One method is by solving we prove it, direct method, and the other one is contradiction method. We solve by the contradiction method. So I can use two different techniques here. The first technique is I will simply solve it and will prove it, and the other is by contradiction method. So method number one, how we can do it? This is method number one for part one. Let's see. You can say, okay, let's suppose that it is true. Okay, suppose the given term is true, and then we will prove that mathematically, we will check with mathematical support that whether it is true or not. So we suppose that, let's say x minus 4 square is greater or equal to 2x minus 9. Now, just by a simple example, I can explain this. How using this one, how supposing that it is true, we can prove that this is algebraically it is true. I can give you one example. For example, if we say, if we have to prove something, and we let's suppose we have to set a hypothesis, and the hypothesis is that if you will not drink the water for 5 days, it's not possible to survive. Just a simple example I'm giving. That is a hypothesis. Now, after that one, if it proves that anyone who don't drink water for 5 days cannot survive, then that will become a rule. So similar technique I will use here. What I will do, I will say, I will expand this one. On expanding this one, it will become x square minus 8x plus 16 is greater or equal to 2x minus 9. I can say it's x square minus 8x plus 16. Bring them to this side, minus 2x plus 9 greater or equal to 0, and that will become x square minus 10x plus 25 greater or equal to 0. Now that is a whole square. That's a complete square. I can say is x minus 5 whole square. Now that is true, which is true. For all x, this a we write when a in this way, so we read it for all, which is true for all, because you know, if for all x real numbers, so it means we can say, as in the question is given for all real values of x. So this is true for all x belongs to R. For all real values of for all real values it is true, because if we take the square of negative number even, it will be positive number, or maximum it can be 0. So it means our hypothesis is true. So therefore we can say that if it would not be true, then this general result will not be true. So that is why we can say that x minus 4 square is greater than equal to 2x minus 9. Alternative way is method number 2. I will do it by contradiction. This was method number 1. Method number 2 is I will do it by contradiction. I will say let x minus 4 square is not greater than equal to 2x minus 9. If it is not greater than equal to 2x minus 9, it means it is opposite to that one. It is strictly less than. Then what will happen? Because it's not greater than equal to this, so obviously it will be less than this one. X minus 4 square is less than 2x minus 9. Now, if it is less than 2x minus 9, then let's expand this one. It will become x square minus 8x plus 16 less than 2x minus 9 will become x square minus 8x plus 16 minus 2x plus 9 less than 0, because when we will shift it to the other side, it's going to be x square minus 10x plus 25 less than 0. Now this become a whole square, x minus 5 square less than 0, which is not true for all. It's not true for all, which is not true for x belongs to R, because if you take any real number, even negative, its square will be greater than 0, will not be negative. So which is not true. It means our supposition was wrong. Because of that wrong supposition, we got a wrong result. So therefore, we will say, therefore, our supposition is wrong. If supposition is wrong, it means its opposite will be true. Mean we can say x minus 4 square is greater equal to 2x minus 9 for all x belongs to R, for all real values of x. So we did it by contradiction. So any of these two techniques can be used. I personally prefer contradiction method. Now part 2 is show that the following statement is untrue. Now, what is the statement that we have to prove is untrue? Mean in general it is untrue. Is 2n plus 1 is a prime number for all n where n is a natural number. Now we have to prove that it is. So we will just give one example. In such cases, when you have to prove something wrong, just give one example. Then in general that will become untrue. So what I will do, as it is given 2n plus 1, we have to prove it is not prime number for all values of n. Okay, I will first take n is equal to 1. What it will become 2 power 1 plus 1, which is 3, which is prime number. Okay, then take n is equal to 2, is 2 power 2 plus 1, 5, which is prime. Let's take n is equal to 3, is 2 power 3 plus 1, that is 8 plus 1, 9, which is not prime. Yes. So we give one example where it proved that for all n belongs to n. For all natural number, it's not true that every time we put n, we will get a prime number. So therefore, we can say, in general, we can write the result 2n plus 1 is not a prime number for all n belong to n. For all natural number, it is not a prime number. It can be, but not every time. And that was required to prove. We prove it here. Next is question number 4. which always long question about using the binomial expansion. Now using the binomial expansion, we have to expand it in the ascending power of x for the first four terms. Now in general, if I will write the binomial theorem, the binomial theorem is a plus b to the power n is equal to a to the power n plus n a to the power n minus 1 b plus n into n minus 1 over 2 factorial a to the power n minus 2 b square plus n into n minus 1 into n minus 2 over 3 factorial a to the power n minus 3 b cube, so on. At the end we write b to the power n. But right now we have to expand for first four terms only. It means use the formula till this one. The higher order terms, no need to write. So let's write. If I say my a in this case, what is a? This is a and this is b. I can write it b is equal to, first I can write it 2 plus minus 1 over 4 x to the power 6. So this is a, this is b. Just replace the values of a and b here. And what is n? N is equal to 6. So you can get replace a, b and n in this formula till this one, because no need to write the higher order values. We just have to write for the first four powers only. For first four terms we need to write only. So that's why we will just write for first four terms 1, 2, 3 and 4. No need to write this one even. I will just ignore it for the higher powers because we don't need for the higher order powers. So just replace, put the values of a and b here. If I will put the values of a and b, it will become 2 minus 1 over 4 x to the power 6. So using that one, what is a? A is 2. I will say 2 power 6 because n is 6 plus 6 2 power 6 minus 1 will be 5. And b, what is b? B is minus 1 over 4x. And plus n is 6 into 6 minus 1 will be 5 over 2 factorial. And what is a? A is 2. So 2 power 6 minus 2 will be 4. B is, we know, minus 1 over 4x to the power 2 plus n is 6 into 5 into 4 over 3 factorial a to the power n minus, what is a? A is 2, 2 to the power 3, and b is minus 1 over 4 x to the power x to the power 3. So just simplify it now. It will become, now what is 2 power 6? If I will take it, 2 power 6 is 64. I can write it 64 plus, now let's solve this portion. If I will say, instead of plus, it's better because this plus and minus will become minus. One step I can. This plus and minus will be minus, and it's going to be 6 into 2 power 5 time, in bracket I can write this minus 1 over 4 also. That makes minus 48. So it will be minus 48x. In the same way, let's solve this portion. Plus, I can say it is 6 into, let's write it in this way, 6 times 5 times 2 power 4 and over 2 factorial is 2 factorial multiply with this. When I will take for minus 4 square, it will become 16. So multiply 16. That will make 15. So I can say it's 15x square. 15x square. And then plus this part. Now I will solve how it will be. Again, I can use calculator. 6 times 5 times 4 times 2 cube over 3 factorial, and then here if you want to write it's better, multiply with negative 1 over 4 cube. That will make minus 5 over 2. So minus 5 over 2 x cube. I will write it minus 5 over x cube. So here it will become minus 5 over 2 x cube. As we need to expand it till 4 powers only. So we did that one. Okay, that is done. Part A is done. Now for part B, it's given that x is small. So the term x power 4 and the higher powers of x may be ignored. So show that that is equal to this one, where a and b are the constant to be found. So this one we already expanded. We know that when we expand it to first 4 terms, ignoring the x4 and higher powers, we need this one now. How I can do? It will be pretty easy. It will be same, just this sign will change. How slightly this sign will change? All will be positive sign actually. There will be no negative sign in this one. So you can say if you write 2 plus 1 over 4 x to the power 6, because there is no negative sign involved here. So that is why all values will be similar, except there will be no negative sign. So it can be 64 plus 48x plus 15x square plus 5 over 2 x cube. That will be. Now adding both of these, we have to prove it will be of this form. So add them. If I will add them, it will become 2 minus 1 over 4 x to the power 6 plus 2 plus 1 over 4 x to the power 6. That will be equal to, okay, write their values now. 64 minus 48x plus 15x square minus 5 over 2 x cube plus 64 plus 48x plus 15x square plus 5 over 2 x cube. So this this is 48x. This minus 48 with plus 48 will cancel, and this minus 5 over 2x cube will cancel with this. So we are left with 64 plus 64, that is 128. 15 plus 15 is 30, 30x square. So you can check it is of the same form or not, a constant, and then this one where a is 128 and b is 30. So I can say a equal to 128 and b equals to 30. That was required to prove in this one.